Hello and welcome to lecture 21 on data visualization. So in this lecture I'm going to start by sort of introducing data visualization, run through sort of data types and sort of flick through sort of some of the more sort of standard ways of presenting data, sort of different kinds of charts. Do a little bit of a sell also on beautiful data, how how aesthetically pleasing data can be and its role in art. Then I'm going to go on to some of the options that exist for drawing charts using JavaScript. The many libraries that are out there for that. Then I'm going to go into using Plotly for that. I kind of picked Plotly mostly out of a hat, but it seems pretty good for what I needed to do. So I'll show you how you can use Plotly to draw graphs and how you can use Plotly to overlay data on top of maps. Okay, so well, data visualization, it's pretty obvious really. We're kind of graphically representing data in one or more dimensions. So you've got like one-dimensional data, like some kind of line, I guess. Then you've got two-dimensional graphs, three-dimensional graphs. And often, these days data can be, 10 dimensions, 100 dimensions, and so on and so forth. And data visualization is the trick of, presenting the data in a way that we can sort of easily understand it. So we can see trends over space and time, relationships between data items, and so on. And so good data visualization will be easy to understand and tell us useful information about the data. And because there's lots of different types of data and people try lots of different ways of doing this, there's a large number of data visualization methods. So in this introduction I'm just going to skim through some of the more typical ones, but there's a lot of them out there. So the type of data that exists will obviously also determine the nature of the visualization to some extent. So the sort of classic is numerical data of some sort, like integer data, float data, and so on and so forth. Often, as I said, with multiple dimensions, you can get 1,000-dimensional data these days, or much more than that. And then we have, so that's numerical data, and then we have network data, where the data is not a sort of number, but it's a relationship between one node and another node. So one node, is connected to another node, and that connection might have a particular direction, possibly even a certain strength. So in a social network, for example, I've got all the friends that I'm linked to on Facebook, and then each of those friends is linked to other friends and linked back to me, and so you have this complex sort of network structure, and that's kind of represented in sort of network type of data. Then we also have spatial geometric data, so maps are the classic example where the data is linked to a particular point in space, and you obviously have maps of the brain as well and this kind of stuff, but map data is the sort of obvious thing there. Then we have categorical data, so I might say that Freddie, my dog is a certain kind of animal, which is a mammal, right? I'm putting that, Freddie the dog into certain kinds of categories of dog, animal, and mammal. And then we have kind of ordinal data, where you have sort of, let's say, several different items, several different categories, pretty much like small, medium, large, but there's an ordering relationship between these categories. So small is less than medium, which is less than large, but there's no sort of number or absolute size associated, just a relationship of this being less than this and this being greater than that. So they're ordered, but they're not numerically ordered. Yeah. So clothes sizes would be a sort of example of that, right? We don't know how big a small is, right? And it varies with different generations and countries and so on and so forth. But we know that the small is less than a medium, regardless of any of that stuff. Another sort of factor to consider with all this data visualization is the sort of orientation of the axes that you're using to present your data. So three typical ways for this is rectilinear, which is the most popular, right? If we're doing a standard graph, you have one axis, the x-axis, and that's perpendicular to the y-axis. You might have a z-axis, which is perpendicular to both of these. And you have parallel, where you just have the axes are all sort of in a single line, and the data sort of flows between the different axes. And I'll give you some examples of that. And then we also have radial plots, where we're using the sort of angle to encode different bits of information. And again, I'll give you some examples of that. And other thing you might want to think about when you're doing your data visualization is the scales that you're using. So sort of classic difference here is between the sort of linear scale, which you're presenting the price of diamonds on, and then you've got the log scale, logarithmic scale, and you can see some sort of patterns and attributes on one scale but not another, right? You might think, well, this looks kind of a bit random really, but once we plot this on a log scale, we can then see that, you know, actually there's a logarithmical relationship between the caret and the price, a linear logarithmic relationship, whatever that is. Yeah. So by choosing scales appropriately, you can present different aspects of the data. Another aspect of that is that when you're choosing your range of your graph, for example, then you can present different aspects of data. So people, you know, sometimes will present a graph that kind of goes up like that, and people think, wow, that's really amazing, that graph's going right up like that. But then if you look at the scale, you know, it's between, 20,000 and 20,001 or something. So actually the number's not changing significantly in relation to its actual size, but because they've shrunk the range down, it looks like it's changing a whole lot. So the scales transformation can, you know, produce rather deceptive statistics, but they can also illuminate things as well in different ways. So now I'm going to just run through a few of the very basic examples just to sort of get you in the mood for drawing graphs, or charts as they're called. Charts are sort of general name of which graph is, you know, a sort of one of the graph is a type of chart basically. So here we've got 2D line charts. So here we have got 4 cities in this case, and we're giving each of these a different color, and we're also using markers here. So it's a combination here of lines and markers. We're plotting the temperature, seasonal temperature for each of these different cities in a line in a totally standard way. You can put these into 3 dimensions, which may not be helpful. It's helpful if there's a lot of overlap, not helpful if there isn't. And then, you know, so we can see the trends, you know, in 3-dimensional map there, line chart. Then got an area chart where you're kind of coloring in the area below the lines. I've never quite seen how that's illuminating, but, you know, they're quite popular, so I presume there's context in which this is useful. And we have these very aesthetically pleasing stream graphs, which are sort of a variation of this, but then they're flipping. There's data on the sort of above and below the sort of the axis here. So you're showing, you know, this is a Twitter stream graph for Obama. So you're showing all the different, I presume this is time here, right? And so you're showing all the different issues as they sort of rise and the sort of ebb and the sort of, what's it called? The ebb and the retreat, flow and retreat, something like that, some kind of tidal metaphor. Anyway, they're kind of, you know, increasing and decreasing different issues over time as, you know, various things, you know, are deemed to be relevant. So anyway, quite sexy, but again, I'm not quite sure, you know, how entirely useful they are. And then this is a classic sort of science one, right? You've got scatter plot, so you're not drawing a line with the data because this would be some kind of crazy line, right? But you're just marking the data as individual points on your chart. And then you might find that there's some kind of overall sort of trend or whatever amongst all these different points, which might represent as a line there. It's sort of fitting a line to the points, that is. And also you can draw these things in 3D. You know, that's a helpful way to do it. So in general, there's no right data visualization. You know, there are ones that are useful and ones that are not useful. Yeah, so if this is useful, then, you know, you could, you know, then you just kind of go for it, yeah? And we've got bubble charts. So here we've got a rectilinear sort of 2-dimensional graph, right, where you've got time on the bottom, and then you've got the production budget up here, and then the color here corresponds to the film, right? And then the size of the bubble corresponds to the sort of overall, the gross, how much money the film made, yeah? So here we've got Titanic in 1997, you know, presumably had a production budget of 200 million, and then, but its actual grossing was, you know, is the sort of size of the bubble, which, you know, we don't have a scale for that, but, you know, bigger, let's say, in the Star Wars Episode 1, which frankly wasn't very good, yeah. So yeah, we're using the size of bubbles to encode some numerical feature of the data. We can do the same with maps. So this is spatial data, because, you know, the size, each bubble is sort of located on a specific country, right? And then the size of the bubble can be used to encode population or smoking or, you know, obesity or some statistic like that. That's what they're often used for. Then the classic bar chart, right? So the height of the bar corresponds to some numerical quantity, and then you can also sort of break down that height into sort of subcategories, like, you know, in this case, it's what the Coen brothers and, you know, their awards, and then broken down by the categories of the films they've made. So, you know, it can be quite a rich way of displaying data bar charts. You've got tree maps. So yeah, I don't fully understand tree maps, but they kind of have a category, right, which is determined by the color here, right? And then this sort of, each category kind of breaks down into sort of subcategories, which is kind of like a tree structure, right? So this is the sort of root of the tree, and then this sort of subroots, and then these are subroots, you know, sort of branches or whatever, breaking down to, you know, the twigs at the end of the branches and all that, yeah? So this, we could use this to show sort of exports, and then break down the different exports by different categories, which may be what this is doing, or show the tree map by countries, and then each country would have different kinds of exports. You know, it can break down any kind of tree structured data we can represent using this tree map. And again, going back to science, so this is, we've we've got two-dimensional data here. We've got sort of x-axis and a y-axis effectively. And then the color represents the sort of third dimension of the data. In this case, we've got what are these startups? So these are the in food and grocery startups. These are different points in time. And then these are how many deals they've made at each different point in time. So did lots of deals in Q1 of 2015 and like not so many deals in Q1 of 2013 or something like that. Yeah, often used a lot in science, as I said. And then we have a Choropleth map, which is a sort of heat map of spatial data effectively. Yeah, and this is kind of literally a heat map, right? We kind of where the kind of color of an area corresponds to the highest maximum temperature, sort of according to the scale. And so you kind of draw regions on a map and then color code them to encode a numerical quantity associated with that particular region. So this particular region here, you know, is associated as a maximum highest max temper is, you know, 42 or 30, 39, something like that. Yeah. And then cartograms, which are rather fun, right? So you have a cartogram refers to it's kind of a map, but then you're distorting the map to encode some numerical quantity associated with the country on that map. So in this case, we're kind of we can see that this is the predicted population in the year 2100, where it's been like 11.2 billion. And this is the distribution of that 11.2 billion people over the world. So you can see that India is predicted to have a high proportion of the 11.2 billion. And that's shown by, you know, making India sort of larger relative to its geographical area. Whereas sort of, you know, North America, you know, Alaska should be smaller than that, right? So it's only approximate. But, you know, the size of America then is proportionally less because, you know, relative to the rest of the world, they've got less population. So, you know, it's quite a nice sort of infographic, that, right? So pretty much all of those were rectilinear plots. Now I'm just going to flick through some of the parallel ones. So the parallel ones, you don't have a single axis that encodes some quantity like maths or price or something like that. Instead, you have multiple axes encoding, and it's just all in parallel, encoding a single individual quantity. So this is the score in this parallel plot. We've got the score for maths, the score for physics, the score for dance, the score for drama. And so each of the students get scores in each of these kind of courses, modules, whatever, and then that's encoded by this sort of how this line sort of moves across these different axes. Yeah, so the orange person got, you know, 85 for maths, 95 for physics, and so on and so forth, and then the blue person got 65 and so on and so forth. So it's showing sort of individuals of some kind, you know, who are getting different values for different scales effectively. Yeah, so we can see sort of whether all the pupils get similar marks for dance, and we can see sort of correlations between the different individuals using this kind of representation. And we can get much more complex parallel coordinates plots. So this, I think, is some kind of cars or something like that. And these are all the specifications of the different car models. And then so each blue line is a particular model of car, showing its cylinders, displacement, power, and so on. And so we might possibly see, yeah, and so each car is produced in a different year. And so we might see some sort of correlations, or sort of where we got points like this, we can see they've all got points in common, which might be a useful point to know. Yeah, you might say, well, hey, you know, maybe there's a space in the market for a seven-cylinder car or something. And these parallel coordinates plots can be much more kind of complicated. These are a few examples I took from Kai's lecture material. So, you know, some fancy stuff, right, if you really want to get serious about parallel coordinates plots. Now we get into radial plots. So you've got the classic pie chart, where you've got like a sort of typically 100% divided up in different ways. And so the sort of the angle here corresponds to the proportion of, you know, this particular attribute. So Facebook has 27.7% social media engagement, whatever that means. So yeah, we're using the angle here to encode particular quantities. And you also have these nice kind of chord diagrams. That's a slightly frivolous example of who kissed who in Friends. So chord diagrams are good for network structures. So here on the outside, we have all the different characters in Friends. And then if you have a line from one character to another character, that means that that character kissed another character in Friends. And heaven knows who gathered this data. But it's quite a nice visualization of this sort of network structure about, you know, lip contact in Friends. Then we've got radar charts. So I often recommend these for my students when they're doing the projects and presenting the results of their evaluation questionnaires. So here you have the sort of distance from the center encodes the sort of level of difficulty of a particular task. This is like gymnasts, right? And they've got different tasks. Sorry, the different score on the different tasks. So this is how difficult the task was, how well they executed it, their landing, the style, and the creativity. And so each of the gymnasts has a particular shape within this radar. Yeah, so the green one, it's pretty good on most things except execution and style, whereas Gymnast 2, is great on execution and good on style, but not so good on the other points. So you can see the different performance of the different gymnasts by looking at their shapes, and presumably the one that has the greatest shape, the most area inside the shape, would get the biggest score, something like that. So these are some very standard examples, and pretty much every charting library will support most of them. Yeah, and just to talk more broadly about data visualization, there's a whole sort of movement now, both within science but also within art, about the beauty of data and the aesthetic qualities of data visualization. A real appreciation of looking at these kind of renderings of data in different ways. And so if you go to, there's lots of a lot of the art exhibitions I go to, they'll have a few works, doing different kinds of data visualization of some kind. A lot of museums will have this kind of stuff as well. Yeah. So there's a lot of artworks based on data visualization, and there's a lot of appreciation both within science and humanities of the, the importance of this. Yeah. And so one of the first, the sort of classic pieces of data visualization, this man, Charles Minard, who created this visualization of Napoleon's march map. So it's very nice and, justly celebrated, right? Because, not only was this highly original at the time, so it's showing the, but also it's rather beautiful still today, right? So it's showing the, Napoleon took this enormous army, marched all the way to Moscow, fought various battles on the way, lost most of his army, to cold, as well as being killed in battles, obviously. And by the end, they came back and there was virtually no one left. So this is showing, across the bottom here, you've got the distance. I'm not sure what the height encodes, but, and then here you have, I think the width of this thing encodes the size of the army. So you can see as they get, towards Moscow, they're all desertions, dying from cold, killed in battles and all the rest of it. There's probably some battle there, right? And so by the time they get to Moscow, there's not a lot left, right? And then, less than a third, probably a quarter left, right? And then they start the long, weary march back from Moscow with no food in freezing conditions. And by the time they get back home, there's like no one left. They've all died, yeah? Or, pretty much all died. So it's a very nice visualization of a bunch of data about Napoleon's, desperate 1812 campaign in Russia. This is more sort of on the art spectrum, right? We've got visualization here, Beethoven's Symphony No. 5, don't ask me about details of that. Or there's visualizations of poems. Again, I was looking at sort of some of these data visualization websites. So you can see, these are fantastic and structures, right? They're very beautiful things to look at. And a lot of them are kind of animated, right? So you can see them sort of changing in 3 dimensions, as stuff happens, yeah? So if you want to have a little look at this, there's sort of the Information is Beautiful website, and there's a Pinterest group there with like 25 data visualizations or whatever. So, feel free, in your coursework too, to, step out a little bit outside the box, right? If you want to do something like that, I'd be more than happy, yeah? Because this is like, there's a sort of whole movement behind this beautiful data stuff. Okay, so that's the background to it, right? Now, how do we do it? So in JavaScript, we've got tons and tons of choices, yeah? So it's typical JavaScript, right? The moment you start looking to do something in JavaScript, you find like 20 different ways of doing the same thing, 20 different libraries written by different people with different levels of quality. So with charts, no exception. Heaven knows how many chart libraries there are for JavaScript. In the resources section, I gave you sort of 3 links to comparison review articles. I'll only give a few examples here. I can't possibly list all the various JavaScript charting libraries, and there'd be very little point to doing so. So there's sort of a rough split between kind of commercial libraries and sort of completely free libraries. So the commercial libraries are things like high charts or am charts. So they're often sold to, stock or trading companies or financial companies, this kind of stuff, or, other kind of commercial uses of charts. So they're producing a product that's very high quality. They usually have a free option. The free option be sort of limited in the sense you might have to have a logo there or something like that, or a certain number of calls per month or whatever. So they're good quality. They're probably high performance. But, if they change the licensing options, then you wasted your time learning them, yeah? On the other hand, there's plenty of good free chart libraries. So personally, I wouldn't bother with the commercial ones. You've got Plotly, which is the one I've chosen. There's VegaLite, Chartly, Chart.js. So I haven't worked my way through all of these. They're all popular. And they're all good, probably, yeah? So in this lecture, I picked Plotly.js. So it's free, easy to use, it's open source, so, all the rest of it, yeah? So I think there is a commercial, there's a company that that sort of built it, but sells stuff based on Plotly. But Plotly itself, I think they've kind of made open source and all the rest of it. Yeah, so it is free and easy to use. You don't have to sign up or anything like that. It's got very good documentation. If you look on the Plotly website, there's tons of examples of different chart types and code that you can use to generate those different chart types. So it's great, and the reference section's really good. So that's really useful and important. It's got loads and loads of different chart types. I mean, Plotly's pretty comprehensive, and so in terms of drawing the basic stuff like graphs, it's got that covered. You can do radar plots, probably do chord diagrams, but most importantly, not all of the chart libraries that I came across will support maps, and so I know at least a couple of you are doing projects based on maps, so I wanted to pick a library that also did maps. So for all these reasons, Plotly seemed like a good choice, but one of the other ones is probably equally a good choice, so feel free to use a different chart library. I'm in no way saying use Plotly or lose the marks. I'm just saying this works, but if something else works for you, then that's fine too. Yeah. Okay, so in this section, next section rather, I'm going to move on to show you how to draw graphs with Plotly, and then for the last section I'll show you how to draw maps. So there's not a lot to say as by way of introduction, so I'm just going to work through an example of drawing a simple graph, then I'll show you how to draw a more complicated graph, and really, when it comes to, if you decide to draw graphs, all you'll be doing is what I'm doing here, which is like lightly modifying some of the Plotly examples to make them work for your code, yeah? And I'm totally fine with that. I understand that's the workflow with this kind of stuff, yeah? So this is my HTML page, right? So I need to include the Plotly JavaScript library, so dead easy off some content delivery network. Then I need to have a div that's going to hold the charts, right? I need to specify where on my page I want Plotly to insert that particular chart. And then I've got a script tag, and in the script tag I've got all the the code to set up my graph, yeah, and it's pretty easy on Plotly, which is another reason I picked it, yeah. So what we have are these traces. So each trace is a line or grouping or set of marks on my particular graph, and I can have multiple lines or multiple traces on any particular graph. So these traces, in this case, contain an array of x and y coordinates for each of the points on the graph. Then I'm specifying how these x and y points should be drawn, in this case markers or blobs or whatever, or lines in this case. And then I'm specifying, some stuff like the name of the data sets. This will be displayed on the sort of legend on the right. And then we've got the marker type, so you can give it a color and a size, or, and then if it's a line, then width of the thing or whatever. Yeah, so we're just setting up in each of these traces how we want the Plotly to draw the lines or groups of points. And then the data that gets fed into the graph is an array of these different traces or lines, yeah, or groups of data. Then we got the actual layout, which specifies things like title, the x-axis, the y-axis. I could probably specify ranges on here, but I haven't got into ranges for this. I'm just relying on the auto range features. And when you've set everything up, all you have to do is do Plotly new plot, specify the div where you want the plot, and this can be the ID of the div, or it can also be a reference to the div in JavaScript. And then we specify the data that I just described, and then the layout as well. We just pass that in, and then we'll just draw it. It's that simple. And yeah, the chart div, it's just the ID of the div. And then when you look at it, there we go, right? So we've drawn this fairly random and unexciting data. It's auto-ranging, right? So it's just the minimum and the maximum of the data here. Here are the labels I gave it, and here's the legend with the name that I gave to data sets. Title of the graph, and the line I styled blue, and these blobs I just styled red. So you can see it's dead easy, right? Shouldn't cause you any difficulty at all. So next I want to show you a slightly more representative example, we might say, of drawing crypto data, yeah, because I know that a lot of you are doing crypto, so I might as well, give you a little bit of a head start with drawing the crypto data, I thought. So in the previous example, I just had one graph I wanted to draw. In this case, I want to draw a different graph for each of the cryptocurrencies. Yeah, I've got Bitcoin, Ethereum, Litecoin, and Tron. It's kind of based on my data uploaded example, yeah. So I want to draw 4 graphs. I could, of course, put them all on the same graph, or do some kind of, stream graph or something fancy, which is fine too. But in this case, I'm just going to do the bog standard thing of drawing 4 separate graphs. And in order to draw graphs, and I'm going to have to do this with all the examples in this lecture, I need some data, right? So I could, pull the data off some site and all that, but, that's a different lecture. So here, for all of my examples in this lecture, I'm just going to generate random data that looks a bit like the real data, yeah? So here I've got my JavaScript file here that's going to generate some random data that I'm going to use to draw these graphs. So this is my currency data, so I'm not going to bother with explaining all the details. You've got the example code anyway. You can have a look through it if you need to. But if you have a little look, the sort of crucial and interesting bit is here, where we're at. Yep. So all I'm doing is creating a data structure here called currency data, which is an array of currencies, right? And each currency object has a name, the average price, which I end up getting rid of in the end, and an array of x coordinates and an array of y coordinates. So these x and y coordinates are what I'm going to use these are going to be the points on my graph. I'm going to use the average price to generate random data that's going to be like 10% greater or 10% less than the average price. It's just going to fluctuate around the average price, the random data, and then it's going to generate that and bung it into these x and y arrays here. Yeah, and that's all this code is doing here. So here we've got the actual website code, and we've got a function that plots the data. So first thing I'm doing, I'm calling that function I just described very briefly that generates a load of random data for the currencies. And that's this currency data here. Then I'm going to work through each currency, and I'm going to build a trace. So think if you remember, trace is like a line. That's right, isn't it? Yeah, same as this trace here, right? A trace is a sort of grouping of data. So here we've got the trace, right? A trace a particular line on a particular graph, and within that trace I'm passing in the data that I've generated randomly but with this function. Yeah, so I've got a bunch of x coordinates, a bunch of y coordinates, and the name of the currency as well is stored in that data object. So then I build up my trace or collection of data, collection of points that's going to plot on that particular graph, and then again I get a reference to the particular div that I want to put the currency into. Yeah, so the Bitcoin I want to put in the Bitcoin div, so I can just get element by ID, currency name plus the div, because as I said, you can pass in a reference to the div as well as, you know, the actual just name of the div. We might as well get a reference to it to be on the safe side. Then I give it a title, which is making Bitcoin uppercase. And then the layout, standard stuff, you know, the title, you know, time and price. And then in this case, I've only got a single trace per graph because I'm not drawing all the cryptocurrencies on a single graph. I'm drawing them on 4 separate graphs. So I've just got a single trace inside my data structure. And then I do plotly new plot to plot the data. Yeah? And that's what it looks like. Let's just have a little demo. So that's the simple graph. And then here's my cryptocurrency one. Yeah. So in this case, I'm calling the function to redraw it every second to give you sort of the illusion of live data coming in and changing, yeah, although it's just completely random, which is why it's just going up and down like that. Obviously, if the data was changing sort of in a more sensible way, it would sort of be moving along like that, right? But it's just a demo, yeah? So we've got the Bitcoin, the Ethereum, the Litecoin, and the Tron. They're all being redrawn every second. And again, obviously, in this case, I'm just using set interval to redraw it. You know, you should be redrawing it in response to a WebSocket message that's pushed from the server or from the serverless cloud. So the cloud's going to push a message containing new data, and then that should trigger the redraw of your plots. All you have to do is, you know, call that same code and it'll just redraw it for you. There might be a way within Plotly, I haven't looked into it, of you know, just changing the data structure and calling redraw to make it a bit more efficient. But you know, and if you can find that way, great. But I'm not that fussed if it's not like massively super high blazing performance, something like that. Yeah. Okay. So that was the numerical data being plotted in a bog standard graph. Yeah. I think it covers a lot of the projects you're doing. But I thought it was also worth covering maps, because at least 2 of you, I think, are doing map-based data. So I thought, you know, to try and make things a little easier for you, I'd sort of talk you through how you could use maps on Plotly, and it's sort of not that trivial. So it's you know, I'm kind of glad I covered it. Yeah. So Plotly supports 2 kinds of maps. Yeah, you've got the kind of basic map that has no details really about roads or cities. At least as far as I could see, the basic maps are very basic. They're kind of country outlines, pretty much. Or Plotly supports integration with Mapbox. And Mapbox has nice, beautiful maps, way better than Plotly maps. You know, you've got streets, cities, all kind of information you can want. And what you can do is you can sign up for an API key that lets you have 50,000 free calls per month. So for each view of a Plotly map, Mapbox map, that's one of your free calls. So obviously you're not going to use that up in your project. So you sign up for it here, mapbox.com, get the API key. But just be a little cautious about that, because although I didn't have to give a credit card, it does say that it's a pay-as-you-go account. So I don't know what happens if you reach 50,001, and whether you're going to get an invoice for whatever they feel like charging you. So to be on the safe side, if you do use Mapbox, I recommend you delete your account after you've demonstrated your coursework and everything's finished. Yeah. So the first map example I'm going to give you is a bubble map, and the data for this, well, I thought, well, let's use sentiment data. So I randomly generated some sentiment data for different points across London, and I've generated a load of random points across London and generated some sentiment for each of those points. Yeah, so this is the kind of map you might use to show, properties or hotels or something like that, and reviews, where maybe the bubble maps, the size of the bubbles will correspond to the positive nature of the reviews, or I think one of you is doing a kind of stuff on crime statistics. So I think there's a crime map of London, right, where you can get different sized blobs, corresponding severity of the crime or the number of the crimes. Then you can click on and drill down to all the kind of details of that. So you can use the size of the bubble on a bubble map to encode information about something that happened or some feature at that particular point in space. Yeah. So in order to I'm just generating a random points here for this example, because it's just an example. So what I did is I drew a box around London, and then generated random points within that box. So I had random bubbles mapped into particular points across London. But to generate these points, I needed the longitude and latitude of a box enclosing London, right? I can't generate random longitude and latitude points for London without knowing the longitude and latitude of London, yeah? So so when you're doing map stuff, you often need longitude and latitude data for a place you want to display. And the easy way to do this is just use a website. So I typically use latlong.net, but there's probably other ones. So it looks like that, right? But let's just do a demo. So to find a point, let's just refresh it, yeah. So suppose this gives us a world view, and then suppose we want to go to London. So it'll find us a place, doing standard map search stuff. And then we can sort of zoom out. And then if I want the longitude, if I want a box surrounding London, then I need to click on the sort of top left corner, right? And then record the longitude and latitude here. And then I can click on the bottom right and get the longitude and latitude here. And to define a box, all I need is the top left and bottom right points, right? And then I can use that to generate random data points within the longitude and latitude of London. So here's my code for generating random points across London. I'm not going into details, but here we've got the points that I got from that website, right? The minimum London latitude, the minimum London longitude, and the maximum as well. And all I'm doing is randomly generating points within the range here. And so at the end I've got this latitude array, a longitude array, and a bunch of labels that are in this case completely meaningless. I'm just using point plus I or whatever, yeah? But just to illustrate, because obviously we're doing crimes or hotels, then we might click on it or hover it, and then we'd see the name of the hotel or the name of the crime or something like that. So that's my random locations. I'm also generating random sentiment data. Again, I'm not going into details because it's not worth it. But what I'm doing is generating a sentiment object that corresponds to the data structure that comes back from comprehend. So in this case, all I care about is the positive and negative. So it's got and they add up to 1, right? So all I really need to do is generate the positive and then subtract it from 1 to get the negative. So I'm getting a certain number of these sentiment points, and then I'm going to plot them on the locations that I've generated with the other bit of code. So here's the actual client-side website code. So we need a Mapbox token if I'm going to use Mapbox. And what I'm doing here, this is particularly important in the next example, but I sort of left it in for this example, because it's a sensible way to do things, is I have a global variable that I'm calling locations here, yeah? And then the first time that draw map's called, it will generate all the random locations across London. As it happens, it's not a massively... this is a heavy task in the next example. It's not that heavy a task here. And then if locations hasn't been populated with any data, it will then generate random locations across London, and then it will plot the sentiment, the randomly generated sentiment, on those locations. If this thing already has all the locations set, then all it'll do is regenerate the sentiment, because it's the sentiment that changes at the different locations, and then it'll regenerate the sentiment and then plot that sentiment on the same points that were generated the first time. So this is a more sort of efficient way of doing it. We make a call to get location stuff once, and then we redraw the map. We only have to redraw the sentiment. We don't have to regenerate all the points as well. And this is the main function that plots the sentiment. So it starts off by getting this random sentiment data. And then what it's doing here is it's generating an array that encodes the size of the bubbles. Yeah. And so here I've sort of multiplied the sentiment score, the positive sentiment score, by 100. And this is kind of just a hack, really. I fiddled around with it. And when we set it to 100, we're getting a sort of fairly decent trade-off between the number of bubbles and the size of the bubbles. So we can kind of clearly see you know, how much positivity there is at particular points. But obviously this is kind of a parameter, and you might want to change that with different scalings or something like that. Yeah, as it happens, it does change with different scalings, but you know, it may be a bit of fixing required to make it work smoothly on a proper professional website. So we're generating sizes of the bubbles here from the sentiment data. And then with all this stuff, we need a layout, right? In this case, this is kind of mapbox stuff where we're centering the map on a particular point here. We're saying it's got a certain style. I'm using the dark style in this example. And then we've got a zoom level, you know, how zoomed in we are on that particular longitude and latitude. And then data structure. So remember, I generated all those random locations, right? So here I'm putting in the latitude array, the longitude array, and the label array. I'm also putting in the sentiment array. These are which I'm used to encode the size of the markers, and some other stuff about, you know, the markers being red and being, you know, in black lines with 2 and all that. With this example, because I'm using Mapbox, I also need to specify the Mapbox access token that I've signed up for already, and that was sort of at the beginning of the file. It's global, so we just got Mapbox token there. And then we do the same thing, plot the new plot, where we're specifying the div where we want to plot the data, the layout, and the config, so we can actually use the Mapbox API. And this is what we get when we plot it, which personally I think looks quite nice. So the size of each bubble. So I've generated random points across London, and for each point I've generated random sentiment data, and the size of the bubble corresponds to how much positivity is at that particular point. So, you know, again, we can have a little example. So here's the thing, sort of for real. You can sort of zoom in. As you can see, if you zoom in, then the relative size of the bubble stays the same, but the absolute size of the bubble changes. Is that right? Is that getting smaller? Yeah, it is getting smaller, right? Anyway, so that's sort of quite a nice feature of the map. So it's not just, you know, so the closer you get in, the more intelligible it becomes. Now, what I also did, this is my bubble map demo. So I experimented with this, really. So if I refresh it, I've sort of set an interval now so that it draws the map, and because the sentiment might change over time, right? Sentiment's not a static thing. So every 5 seconds, it's redrawing the map with different sentiment data. Same points, as I explained, but different sentiment data at those points. And as you can see, the map drawing is not very smooth, right? It takes a bit of time to pull the map from the API and all this kind of stuff. So if I was doing this on a proper site, what I'd do is I'd have 2 divs, one visible and one invisible. I would redraw the map onto the invisible div and then swap them, maybe using layers, so that you would then see the layer that's just been redrawn, and then hide the one that was, and then redraw, and then draw the next map into the hidden one, and so on, and do this swapping thing. So I briefly tried that, but then it started to get a bit too complicated for a simple example, so I kind of gave up on it. But if you're doing a proper example and what is a smooth map refresh, then the way to do it would be, you know, using 2 divs and swapping them in a clever way. Yeah. Okay. So the last example I want to give you is a Choropleth map. In a Choropleth map, the color in the different regions indicates the value of a property associated with those regions. So in this case, we're representing the population of a US state. So here the population is kind of like above 30 million, right, in California. And here, wherever that is, what's Florida, isn't it? So Florida has, you know, about, you know, 10 million, something like that, yeah? So to plot this data, we need to obviously know the values of how many, in this case, the population of each of the different US states. But to draw the data, we also need to know the boundaries of each of the US states. And that's the tricky bit when it comes to Choropleth maps. And you also note that this is the Plotly standard map sort of stuff, right? And if you zoom in and in on here, you'll see nothing. It's just empty space, yeah? So there may be a setting that gives you a bit more stuff, but generally the Plotly maps are pretty rudimentary like this, which is why they have the Mapbox integration for doing better maps. To draw a Choropleth map, as I explained, we obviously need to know the numerical data to color code the region. We also need geometric data to draw the boundaries of the regions. Yeah, without the geometric data, we can't draw a Choropleth map. There are various geometric data formats out there. Plotly supports GeoJSON and also vector formats. I kind of like GeoJSON. Kind of makes sense to me. Everything JSON makes sense to me these days. So this is a sort of particular specification of how you can encode spatial data within JSON. Yeah, and you typically have this thing like type feature, and then the geometry of the feature, and then you can have some properties of the feature as well. Yeah, and there's a sort of little website on GeoJSON with a link to the full specification if you're interested in it. So these boundary data, you can appreciate, isn't, it's not something you just make up. We could go around on that, website and laboriously plot the boundaries of London, but it would take a very long time. Much easier if we can use a web service to obtain the GeoJSON data we need to draw the regions. Yeah, and one very good source of GeoJSON data is Mapit, and that's essentially what they do. So you can sign up for a standard plan. So if you go to the Mapit website and say, go for the cheapest one you have to pay something for, and then just say there's a box you can tick where you say I'm a non-commercial or a charity user, something like that, and then they sort of charge you $20 or whatever it is, but then they'll give you a $20 refund. Yeah, so that you don't have to use your credit card or anything like that. You just say you're non-commercial, and then as long as you tick that box of non-commercial, you shouldn't have to pay anything to be able to use their API. So once you've signed up, you get the API key, and you can just append it to request URLs. So there are some free, you can call the API a bit without the API key, but it rapidly, if you call it a lot, it'll just start blocking you and you'll get an error message. So you do need the API key if you're going to use it for some sort of serious stuff, yeah? So when we get a Mapit, it has some nice, so you have this idea of areas within Mapit, and it's got these kind of predefined areas. So if I want the London boroughs, I just have to go to this endpoint area/LBO. And I need to do this first because in order to get the GeoJSON stuff, I need the ID of the area that I want the GeoJSON description of. Yeah, if I want the boundary of Barnet, for example, then I need to know the Mapit ID of Barnet. So what you have to do for this example, for London boroughs, I needed to go to Mapit, and then I go to LBO, and then I get this sort of data structure, and this data structure has the IDs of all of the London boroughs, as well as the names if I wanted them. Yeah. So once I've got these IDs, like 2511, that's an ID, or 2505, these are the IDs of London, of particular areas. So once I've got the ID, in this case 2511, I can go to area/the ID.geojson, and then this gives me the sort of the geometry of that particular area. Now this geometry looks hopeful, but as I'll explain a little bit later, we've got to do a bit of fixing to make it fully GeoJSON format. As it stands, I can't use this with Mapit. It needs a bit of tweaking to make it actually work. So that's where we can get the GeoJSON data from. Now I can actually talk you through how we can actually build a Choropleth map using this data. So this little example, it color codes London boroughs using randomly generated sentiment data. So the sentiment data is the same. What's different here is that instead of making bubbles bigger or smaller, I'm actually just color coding particular regions within London. So the first stage to do all this is I need to get the IDs of the London boroughs, the Mapit IDs, as I explained. Using these IDs, I can make separate API calls to get the geometry of each London borough. This is why we need an API key. That's not going to work without the API key. Need to tweak the GeoJSON format a little bit to make it work. Then, just as in the previous example, I'm going to randomly generate a bunch of sentiment data, and then I can create the Choropleth map from the geometry data and the sentiment data. That's kind of a little bit complicated. It took me a while to get this running, I have to say, but it does work. Okay, so I've got a separate, I think it's called location data file, location data JavaScript that generates them, that gets the Mapit IDs for the London boroughs. So I need the Mapit API key, and then I'm building a URL just like the one I explained, where we're calling the LBO endpoint to get the London boroughs, which will give us a data structure containing the IDs of all of the different London boroughs. I can then use these IDs to then call area, as in exactly as that example, /areaid.geojson, again using my API key, and then that will give me that geometry object that corresponds to that particular area. Now, as explained, if we just use response data within Mapbox, then that's not going to work. Yeah, we have to fix it so that it's properly GeoJSON. I don't know why it's not GeoJSON already, but never mind. So a GeoJSON file, typically a geometry object, typically has a type, in this case a feature collection, and then it has a features key, which points to an array of features. And in this array of features, you have an object, and the geometry of those features is specified in the response data. So if you look at this, this by itself doesn't work with Mapbox. We have to add wrap a few bits around it to get it fully GeoJSON, and that's what that's doing there. Yeah. The geometry object that we return should now be in GeoJSON format that will work with Mapbox. So now here's the code that's running on in the actual website HTML page. So just like the previous example, the first time this is called, it's going to get all the London boundaries or the boundaries of the London regions from Mapit. And that's what this is doing here, this get London boroughs, and it's going to store it in this London geometry data structure here. And this is particularly important here because I'm already making at least 31 calls, probably around 30 calls to map it each time this page is each time this code is run. Yeah. So if we want to do a map that refreshes every second or something like that, that's going to make 30 calls to map it every second, which is a lot, right? If I've got a lot of people looking at this stuff. On the other hand, if I just make a single call to map it to pull the data and store it here, then however many times I refresh the page, I'm not making any more API calls to map it. I'm still just making calls. I'm making calls to Mapbox, but not to map it. And there's only one call to Mapbox for each refresh, whereas there's 30 to map it. So first time it's called, it gets the geometry data, stores it here. Second time it's called, it's just called plot sentiment there. Yeah. So here's the function that actually plots the sentiment data. So we get random sentiment data, just as the previous example, nothing different there. Then I work through each of the boroughs. So it's an array here of the geometry of each of the London boroughs. And then for each of the London boroughs, I get the positive sentiment score. And then if it's above 0.5, I make it like red with the transparency of the red varying with the how positive it is. If it's completely positive, it's completely opaque. On the other hand, if it's a negative sentiment, if it's less than 0.5 positive, then it makes it black, and if it's completely negative, then it becomes completely black. So I calculate the color that I want each region to be, and then each region has to be a separate layer, right? There's a separate layer for each region. So in this case, I've got about 30 regions, so I've got about 30 layers. So here we've got the layer object. So the source type's GeoJSON. This is the geometrical structure that I've just built, right? This is London geometry here. And I'm putting it a particular color, making it a particular color that corresponds to this randomly generated sentiment data. So I store my roughly 30 layers here. And then we create our layout object with some standard stuff, Mapbox stuff, where it's centered, blah, 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 blah. And here I'm passing in the layers into the Mapbox object. So I'm saying that the Mapbox is handling the different layers that are being displayed on the map. So that's why passing the layer array here into Mapbox rather than as a separate data structure. And then data structure is just, this scatter Mapbox thing, which is sort of a default. I can't really see the point of that, but it only works if it's there. And then the standard configuration stuff, and then we just do plotly new plot, pass in the div where we want to plot it, the data, which is that stuff, the layout, which is the important bit, and then the configuration, which has the Mapbox API. When we do all that, we get this, which I think I was rather pleased with in the end. And let's have a little look at that sort of live, so to speak. So here we've got it, right? So this is the boundary data that I got from Mapit, and then it's been given a color that corresponds to the level of sentiment. So this is sort of really negative sentiment. This is pretty positive sentiment, right? And then if we refresh it, if you look at Enfield, refresh it and you see it change here. Bit of luck. Enfield hasn't changed. Right, let's try it again. Yeah, there we go. So Enfield's now got positive sentiment, right? So it's just randomly generated sentiment data. So just like the other one, if we go back to my Choropleth map demo, I could set an interval. We could make it, and this would be kind of equivalent to making it responsive to data that changes every 5 seconds. So suppose the WebSocket's pushing data every 5 seconds, this thing, then we could redraw it, like this. Yeah, but you can see, well, firstly, that's a bit slow. So again, you want to do something like having 2 different divs. You draw on a hidden div and then flip it so that the hidden div's visible, and then you draw on the invisible one again. And obviously, here is where it really pays in terms of storing the geometry data, because the geometry of each of these different boroughs isn't changing, right? So I only make a single call to get the geometry data, and then it's just stored within the website. And if this is a commercial website, I wouldn't even make that call to map it. I just store the geometry data as a separate JSON file. But as you can see, and again, we can zoom in, zoom out, and all the rest of it, yeah? I personally think that's quite a nice sort of example of a Choropleth map. Okay, so let's just get rid of this so it doesn't, you know, hammer my CPU. Okay. Righty-ho, so in coursework 2, data visualization is pretty important, right? It's it's the front end of your website, effectively. Yeah, so we've got, I think it's 15 marks, right, for the data visualization components. So I'm expecting you to visualize the third-party data that you've downloaded, the synthetic data, which I'm going to sort out, you know, in the next week, predictions about the third-party and the synthetic data, and also the results of sentiment analysis. You can use graphs, you can use chord plots, whatever they're called, you can use radar plots, you can use whatever, you know, is a nice way of presenting the particular type of data that you've got in your project. And then the website quality, some of the marks for website quality are likely to be linked to the quality of the data visualization. Yeah, if you've done a really nice job, like that Crypto Watch website, of presenting your data, you know, in a nice, clean, tidy way, then you're going to get more marks for website quality. Yeah, and website quality is also determined by the kind of data you've got. So if you spent a long time working really hard on getting some sort of clever data that you're displaying, then you can still get the 10 marks, because I can give you the marks for the work you did on that. But if all you're doing is a cryptocurrency thing, then I recommend you work on the data visualization, because I've given you a lot of you know, hints, shall we say, on building a cryptocurrency website. Yeah. Right, and then resources. So standard stuff, all the examples, I've bunged in the example code there. You've got some examples to motivate you on beautiful data stuff. Here's a discussion of the different JavaScript data visualization libraries, various ones there, and then the sort of Mapbox and the Mapit websites, and the documentation are there as well. Okay, so this lecture, I've introduced data visualization and shown you how you can display data on graphs and maps using Plotly. And the next lecture is going to be on machine learning.